Right, so question 1. A box is on a table. The area of the box in contact with the table is 1,500 centimeters squared. The pressure on the table is 28 newtons per meter squared. Work out the force exerted by the box on the table. Give your answer correct to the nearest whole number. So looking at this question, I can see straight away that I've got 1,500 centimeters squared and 28 newtons per meter squared. So I'm going to have to do some conversion. What I'm going to do first, however, is rearrange this formula because I do need it for force. So pressure equals force over area. Now if I look at force, it's being divided by area, so I multiply by area, and I end up with pressure times area equals force. So that's my equation rearranged. Now I'm going to change 1,500 centimeters squared to meters squared. So to do that, I'm just going to write it down here. Remember, make everything nice and neat. So I've got 1,500 centimeters squared, and I would like to get rid of it. So I need to multiply by over a centimeter, and I would like to convert it to meters. So I need to multiply by 1 meter over something centimeters. So how many centimeters are there in 1 meter? There's 100. Now we don't want meter, we want meters squared, so we need to square all of this. Well, then we end up with 1,500 centimeters squared times 1 meter squared over 100 squared, which is 10,000 centimeters squared. Now from algebra, that will cancel with this, so we end up with 1,500 meters squared over 10,000, and therefore 1,500 divided by 10,000 will give us 0.15 meters squared. So we've now converted that from centimeters squared to meters squared. So now looking back at the equation, force equals pressure times area. The pressure is 28 newtons per meter squared. Multiply that by 0.15 and we get a pressure of 4.2 newtons. Now it does say give your answer correct to the nearest whole number, so that would be 4 newtons. Question 2. A square size of length 8.4 centimeters. Work out the length of the diagonal of the square. Give your answer correct to 3 significant figures. Well, a square would mean that all of the sides are the same. Okay, and we need to work out the length of the diagonal, which could be this right here. Well, then we know that we need to use Pythagoras, so we could take this out. Here's our right angle, then we can label this as A and B, and this, let's do this as 8.4 and 8.4 first, and then call this A and this B. It doesn't matter which way round, and we need to find C. So we know that Pythagoras' theorem is A squared plus B squared equals C squared. So it's 8.4 squared plus 8.4 squared equals C squared. So 8.4 squared gives us 70.56 plus 70.56. Which gives us 141.12 equals C squared. Therefore, to get C by itself, we square root. And the square root of 141.12 is 42 root 2 over 5, which the three significant figures is 11.8, 793. If we do to three significant figures, 1, 2, 3, this is our third significant figure. We look here and we get to 11.9 centimeters. Okay, question 3. The diagram shows a circular pond with a path around it. The pond has a radius of 5 meters. The path has a width of 1 meter. Work out the area of the path. Give your answer correct to three significant figures. So this would be the pond, and the path would obviously be the grey shaded area. So what we can do is find the entire circle. So pretend that the pond didn't exist and just take the entire thing. So that would be a radius of 6 meters, so the 5 plus the 1. We know that the area of a circle is equal to pi r squared, so therefore we have pi times 6 squared, which would give us 36 pi. Next up we have the pond, or the inner circle, and that has a radius of 5 meters. Again, the area is pi r squared, so we have pi times 5 squared, and we get 25 pi. So if we just worked out the entire area of the circle and we take away the inside of the circle, we'd be left with that grey shaded region. So it would be path would be 36 pi, take away 25 pi, and that will leave us with 11 pi. It does say they wanted three significant figures, so if we type 11 pi into the calculator, push SD, we get 34.5575, etc. The three significant figures will be this one here, and we'd round up, so we go to 34.6 meters squared. Okay, question 4. Jake is making badges of different shapes. Badge A is in the shape of a trapezium. Badge B is in the shape of a rectangle. All measurements are in centimeters, so that's good, so we don't have to do any converting. The perimeter of badge A and the perimeter of badge B are equal, so this is an important sentence. Jake needs to work out the area of badge A. Area of badge A is t centimeters squared. Work out the value of t. Okay, so let's look at the perimeter of A. So perimeter, I'm just going to pick this as a starting point and walk around the shape. So I have x plus 3x plus 1 plus 3x minus 2 plus 3x plus 1. So let's do the like terms here. So we've got x plus 3x, 4x, and plus another 3 and another 3. So we're going to have 3, 6, 9, 10x. We've then got plus 1, which is 2, and then we've got 2 take away 2, which would be 0. So we've got a p for shape A of 10x. Let's just put that in a box. And then if I look at the perimeter of B, again, let's pick this as a starting point. This would of course be 4x minus 5, and this would be 2x minus 3. So I've got 4x minus 5 plus 2x minus 3 plus 4x minus 5, 2x minus 3. Now, of course, you could do the quicker way and do 2 times each length, but I just prefer to do it this way so there's no mistakes. So if we add up the like terms, we have 12x, then we've got minus 16, so that's the perimeter of B. So we've got our 2 perimeters for each shape. Now this is the sentence that we needed. They are equal, so if they're equal, we can say that P equals P, and therefore we get 10x equals 12x minus 16. So we need to find x, so we can do some rearranging. So we can do minus 12x minus 12x. That will give us minus 2x equals minus 16. Then we can multiply by negative 1. That will convert this to 2x equals 16. So we've changed both negative signs into positive. And then we need to get x by itself. So it's been times by 2, so we divide by 2. Therefore x equals 8. Now we do need to work out the area, so we need to know the area of badge A. So the area, so A is a trapezium. So if I write up here, area of a trapezium, so that is area equals half the sum of the parallel sides. So if I call this A and this B, they're the parallel sides, so half the sum, so it's of course adding, half the sum of the parallel sides times the height between them. Okay, so what we can do is we can substitute this 8 into the trapezium. So at the top here, for B, this is just going to be 8, and the bottom here, this is going to be 3 times 8 take away 2, which will be 24 take away 2, which would be 22. So using this formula here, I have A equals 1/2 A plus B, so 22 plus 8 times the height, which is 24. Then I'm going to have half 30 times 24. Now I can put all of this in a calculator or keep going, so I can do 1/2 of 30, which is 15, so 15 times 24. In the calculator, 15 times 24 is 360. Centimeters squared. Okay, question 5. ABC is parallel to EFGH. GB equals GF. Angle ABF equals 65. Work out the size of the angle marked X. Give reasons for your answer. So whenever I look at these kind of questions, I think alternate and corresponding angles. So straight away, what sticks out for me is this alternate angle here, meaning that this here is 65, this here is 65. So I'm going to put a 1 here and then write alternate angles. Okay, now I've noticed here that this and this would mean that it's an isosceles, therefore the bottom 2 angles are the same, the 2 sides are the same, so these 2 angles. So that also means that I put number 2 here, this here is 65, so 2 65, and if I just put that here as well. Okay, now I know in a triangle they must all add up to 180, So for 3, which would be here, I could do 180, take away 65, take away 65, which will give me 50. So 3 is 50. And then of course 4th, I know angles on a straight line, add to 180. So therefore if I do 180, take away 50, I get 130. Here I should put angles, a triangle sum. Question 6. When a number is reduced by 30%, the answer is 17,920. What is the number? So to reduce a number, you've got to think we've got an original number, so the original is 100% worth. So if I was to give you a number and it's 100% worth, and I said reduce it by 30%, you'd be doing 100% take away 30%, and that would give you 70%. So if I then said find 70% of a particular number, you would do 70% over 100, or just go straight to 0.7. Of would mean multiply, so you'd have 0.7 times a number. Okay, now we've got the answer to that, which is 17,920. So what we need to find out is this question mark here. So I'm going to change that from a question mark to an X and find out what that is. So if I look at this X, it's being multiplied by 0.7. I need to get rid of this. So to do that, I need to divide by 0.7. Therefore, X equals 17,920 divided by 0.7. So X equals 25,600. Okay, and you can check that, because now if we do check, and if we do 70% of 25,600, we should get our answer of 17,920. So if I do this, which would then of course be this, I do indeed get an answer of 17,920. So you know for sure you've definitely got those 3 marks. Of course there are multiple ways of doing it. That's just one way. Okay, question 7. There are only 4 mint biscuits and 1 toffee biscuit in a tin. There are only 5 mint sweets and 3 strawberry sweets in a packet. So we've got a tin and a packet. Michael's mum lets him take 1 biscuit from the tin and 1 sweet from the packet. Michael takes a biscuit at random from the tin. He also takes a sweet at random from the packet. So what we've got here is 2 events. So we've got event 1 and event 2. Work out the probability that either the biscuit is mint or the sweet is mint, but not both. So if we start off our probability tree, we have our first selection, which is mint and then toffee. So this is our first event. And then we have a second event, which will be mint strawberry, mint strawberry. So if we fill in the probability now, up here being first, for a mint it would be 4 out of 5, and toffee 1 out of 5. And for the second part, we would have 5 out of 8, 3 out of 8, 5 out of 8, and 3 out of 8. Now what you'll notice is that there is no decrease in denominator and decrease in numerator. So for example, if we go through this path, this is 4 out of 5. The next one doesn't drop to 3 out of 4. And the reason for that is because we have a tin and a packet. Okay, so this would be the tin, the first event, and this would be the packet. Now if it was in the same thing, so they were both in tins, then that would occur where they decrease. So just be careful with that. Now I'm going to write here what each selection would give us. So following from here all the way here, that would be mm. So I'm going to write mm. This next one would be ms. Then we have tm and ts. Now it says work out the probability that either the biscuit is mint or the sweet is mint, but not both. So we need to find this one here because we have one mint and one strawberry, and it would be this one here because we have one toffee and one mint. So then what we need to do is remember, going across we multiply and going down we add. So multiplying this would be 4/5 for the mint times 3/8 of the strawberry, and this would be 1/5 for the toffee and 5/8 for the mint. So that would give us 12/40, and this would give us 5/40. So now we need to add these two probabilities. So 12/40 plus 5/40. You do not change the denominators, so that would be over 40, and that would give us a probability of 17/40. Okay, question 8. The diagram shows a trapezium. All the measurements are in centimeters. The area of the trapezium is 46 centimeters squared. Show that x squared plus 2x minus 5 equals 0. Say we've got a clue, the area of the trapezium is 46 centimeters squared. So if we remember what the formula for an area of a trapezium is, its area equals half the sum of the parallel sides times the height between them. So this would be our height, this would be A, and this would be B. So we know this here is 46, so what we can do is write 46 equals half and substitute the values in. So A is 5x plus 3, and then we've got our plus and then plus B, so that's 3x plus 1 times the height, which is 2x plus 3. So we can write 46 equals 1/2, then do the brackets first. So 5x plus 3x would give us 8x plus 4, then times by 2x plus 3. So we can get rid of this half, and we could write 46 equals 1/2 times 8x would give us 4x, and 1/2 times plus 4 would give us plus 2. And then we could write 2x plus 3 in a bracket like that. So just bring that up here, we'll have 46 equals 4x plus 2, 2x plus 3. So we need to do FOIL here. So I'm going to do 46 equals first, so 4x times 2x will give us 8x squared. Outside, 4x times plus 3 will give us plus 12x. Insides, plus 2x times 2x, plus 2 times 2x will give us plus 4x. And plus 2 times plus 3 will give us plus 6. So if I now simplify that, we've got 8x squared plus 16x plus 6, like that. And it says show that x squared plus 2x minus 5 equals 0. So if I now just write this as 8x squared plus 16x plus 6 equals 46, I need to make it equal 0. So I need to subtract 46 from both sides. And that would leave me with 8x squared plus 16x minus 40 equals 0. If I then write that up here again, you should be able to see that I can take out a highest common factor. So what number here is the highest common factor, or what number would go into all three terms, and that would be 8. So if 8 would be the HCF, so I can write it down. 8 goes into 8 once, so we get our x squared. 8 goes into 16x twice, so we get our plus 2x. And 8 goes into minus 40 minus 5 times. And here we have shown that, and that's our 3 marks. Okay, for part B, it does say solve the equation x squared plus 2x minus 5 equals 0. Give your solutions correct to 2 decimal places. So to solve means find values of x. So we can use the formula here. So if we put minus b plus or minus the root of b squared minus 4ac all over 2a. So if I look at this here, I've got a as 1x squared, b as plus 2, and c as minus 5. So I'll write minus 2 plus or minus the root of 2 squared minus 4 times 1. And this actually should be just 1. Sorry. 4 times a, which is 1, times c, which is minus 5, all over 2a, which is 1. Now you need to split these up, so you need to do this adding that, and this taking it away. So if I just write this again, with the difference being the part in red. So doing that, you should get x equals minus 1 plus root 6, which to 2 decimal places would be x equals 1.4494, which to 2 decimal places, which would be here, would be 1.45. And for our subtraction, you should get minus 1 minus root 6, which gives us minus 3.4494, which to 2 decimal places again will give us minus 3.45. Question 9. The graph of y equals f of x is shown on the grid, which is this one here. The graph G is a translation of the graph y equals f of x. So this one here. Write down in terms of f the equation of graph G. So what we need to do is we need to look how the f of x has been translated. So if we pick this point here, we then need to count how many times it has moved across or translated. So 1, 2, 3, 4, 5. So it's translated plus 5. So if our original is f of x, this has now gone to f of x minus 5. So it's the opposite of what occurs. And the reason for that is because if we've got this value here 1, so if I put in this value of 1 in the f of x, this 1 take away 5 will actually be the value of f of minus 4 in the original. And if you look at the value of x when it was minus 4, it's actually the same value that our new value of 1 will give us. So just as a quick shortcut, if it is translated to the right, so if it's gone positive 5 times, if it affects the x, it will be f x minus 5. So this will always be the opposite to what's happened. Next up, graph of y equals f of x. So f of x has a maximum point minus 4, 3. Write down the coordinates of the maximum point of the graph y equals f minus x. Well, these are coordinates, so this is our x value and this is our y value. This is the value that we're interested in because it's to do with the x. So if I put this minus 4 in, I will get f minus 4 bracket. Well, we've got two minuses, so that will be f of plus 4. So what I'll end up having is, as my answer, is 4, 3. Now 3 will stay the same because this is affecting the x value and not the y. 10. X equals 0.015 recurring. Prove algebraically that x can be written as 1 over 66. So what we need to do is get rid of the 1 and the 5. So what I'm going to do here is write x equals 0.015. So I need to get rid of this. So in order to do so, I can multiply. So if I multiply by 10, 100 and 1000, so that would mean 1000x equals 15.15, because don't forget this will continue on and on and on. So I haven't finished here because I need to get rid of this part. So picture this as being 0.15. Just put this here. Picture this as being 0.15. How can I get x to be 0.15? Well, if I just rub this out quickly, I can do x. Let's just write it here. I can times that by 10. Yeah, so it gives me 10x equals 0.15. Okay, then if I do 1000x minus 10x, that's basically like me saying 15.15 take away 0.15, and that gives me just 0.00. So that means I've got 990x equals 15. So to get x by itself, I divide by 990. So I have x equals 15 divided by 990. If I put that into a calculator, I get x equals 1 over 66. Okay, and the final question, question 11. Here are the first 4 terms of a quadratic sequence: 7, 18, 33, 52. Find an expression in terms of n for the nth term of the sequence. So a quadratic sequence will mean that there will be two differences, and then by that point you'll get a linear difference. So that means that the difference will be the same. So if we look at this, we've got 7 to 18, 18 to 33, and 33 to 52. So 7 to 18 will be plus 11. 18 to 33 will be plus 15. And 33 to 52 will be 19. So this here is the first difference. So we need a constant difference, which means we need to go to the second. So this will be plus 4, plus 4. Now a quadratic will be a standard quadratic is ax squared plus bx plus c. But for our nth term we change that to a n squared plus bn plus c. So for a second difference, because it's a second difference, we need to divide that by 2. So that means our first part of the equation is 4 divided by 2, which is 2, and then n squared. So we formed the first part of the equation. Now if we fill that in, we've got 2n squared plus bn plus c. So we've got b and c to find out. Now what we can do is use our sequence to find out what b and c is by using simultaneous equations. So this here is our first term, this here is our second, our third, our fourth, and so on. So what I'm going to do is I'm going to pick term 1 and term 2, and that's going to give us our two simultaneous equations. So just watch and see how this is done. So I'm going to say that here that n equals 1. So if I'm going to use this, what we've just got here, we've got 2 1 squared plus b 1 plus c. Now of course that all equals whatever is in term 1, and for term 1 in this sequence it's equal to 7. So if I calculate this, I then end up with 2 plus b plus c equals 7, and then I end up with b plus c equals 5 because I take away the 2. So this is my first simultaneous equation. If I now do that with n equals 2, so the second term, I will get 2 squared plus b open bracket 2 plus c equals the value of the second term, which is 18. So now I'll get 2 squared, which is 4, times by 2 will give me 8. So 8 plus 2b plus c equals 18, and then 2b plus c equals 10. So I take away the 8. And this here will be my second simultaneous equation. So if I now set equation 1 underneath this, I'm going to end up with b plus c equals 5. So I'm going to want to get rid of the easiest one first. So if I get rid of c, so I've got plus c, what do I need to do to get rid of this c? I take away. So c take away c will give me 0. So I'm going to put a take away sign here, take away sign here, and a take away sign here. So 2b take away 1b, that's just going to leave me with b. C take away c is 0, and I've got 10 take away 5, which is 5. So I've now found out that b is 5. So I can now use this value to find out the remaining value of c. So I can then do into the easiest equation, so I'll just go for equation 1. If b is 5, that means we put 5 in. 5 plus c equals 5. C equals 5 take away 5, which is 0. So therefore we've got C equals 0. So that means our final equation will be 2n squared plus the value of b, which is 5n, and there is no plus c, so we don't need to write this. So our final answer is going to be 2n squared plus 5n.